Hello friends, my name is Alan. I'm going to show you end-to-end how to get from code to something that's running on a Kubernetes cluster. I'm doing this because I watched many tutorial videos myself and read many tutorials where I didn't find it very concrete. I didn't find that they were actually showing me how to get my own code running, and that's what I was interested in doing, obviously, with Kubernetes. Most other demos were showing how to get some like pre-made, like existing container image running on Kubernetes. But the difference here is I'm going to show you how to get your own code running, and also I'm going to show it on a local cluster because that way you get to really see the components that go into Kubernetes, as opposed to running it on a cloud provider where the details are abstracted away from you and hidden. But they're good to know about when you're learning Kubernetes, I believe. So what I'm going to be doing in this demo is I'm going to be setting up a cluster locally on some machines I've prepared. I'm going to be setting up a dashboard, a web interface, so you can poke around and explore and learn about the components in the cluster. I'm going to be setting up something called Metal Load Balancer, MetalLB, which will give us a virtual IP, like a cluster IP address that you can use to access this cluster independent of the machines that are running the cluster, so you can turn off any machine and still access the cluster. I'll get back to how that works later. I'll be setting up a Docker registry that we'll be needing in order to store the code, or actually rather store the container images that we create from our code so that we can deploy them to our cluster. I'll be writing just a small demo app, just a stateless demo app, and deploy it on this cluster. I'll be making a small change to this demo app and show you how you can roll out changes, code changes to your app. And I'll be demonstrating that the app is running in high availability mode. So as mentioned, I decided to experiment while learning with a local cluster, because that gives me and will give you exposure to the components and the moving parts in Kubernetes. But in real world scenarios, you'd probably want to use a managed Kubernetes engine from one of the cloud providers. Here's some terminology. I thought this was strange. It took me a while to realize that K8S is short for Kubernetes, but that abbreviation is used everywhere. And in Kubernetes, a node means a computer, which could be either a virtual machine or it could be bare metal. And a pod that's kind of a Kubernetes, like a logical host. Pods have IP addresses. These IP addresses are only within the cluster. They're only accessible from within the cluster, so they're not real IP addresses on your network outside of the cluster. They're purely internal to the cluster. A deployment is like a template or a specification of which pods you want created, or which containers you want in your pods, and how many replicas of your pods you want. A service is a group of pods. Services have DNS names so that you can use that to discover. So when you need to talk between pods and you need to discover other services, or reach other services, then you could use the DNS names, so that helps you with discoverability. Load balancer is you can configure your service to be of the type load balancer, and what that does then is it exposes it externally, so you can access your service outside of the cluster, not just with these internal cluster IPs I mentioned before, but externally outside of the cluster if the service is of type load balancer. So that's what load balancer is in this context. And an ingress is a special service which runs an HTTP proxy where you can do things like URL-based routing, or name-based routing, based on domain name, and HTTPS, like SSL offloading. So you can do a lot of HTTP level things in the ingress, and that can then route to all your services that's behind this ingress. So if this is the first time you're hearing these terms, it may be confusing, so I'm going to draw a little diagram to try to illustrate how these play together. I'll start by drawing a box that represents a node. So this is basically, it could be a computer or a virtual machine. And let's say we have 3 of these nodes, so I'll make 3 copies here. Now you can think of the Kubernetes cluster as an entity that's like a software-based entity that's running across all of your nodes. So I'll draw a square that goes across all the nodes, and I'll call this our Kubernetes cluster. Now, as mentioned, within the cluster on the nodes, you're going to be running pods. Let's draw a box which represents a pod here. Within the pods, you're going to be having containers, which are running your actual programs. Container. You might have multiple containers inside a pod. You might have multiple pods running on a node. And so the pods are running like on a single node, but you might have multiple replicas of the pods on the other nodes. So I'll duplicate that here. Put some pods on the other nodes. And it's your deployments where you've specified which containers you want in which pods and how many replicas you want. I won't really draw anything for that here because I think it's more important here to draw the grouping of the pods, which is what I mentioned as services. So let's draw a square around all our pods here. And let's call this our service. Now, the pods can reach each other internally. If you wanted, they can call each other on internal IP addresses, but they can't be reached from outside of the cluster yet. So that's where ingress is useful. So the ingress, as mentioned, is a special service. I'll draw a square for that. Ingress. And the service is configured as a load balancer, so it gets an external IP. Let's say 1.2.3.4. This is now, let's say this is external to the cluster. Let's draw it out here. And now, because it's set up as a load balancer, it'll ensure that traffic can reach the ingress regardless of which node it's running on. And the ingress will in turn get the traffic forwarded to our service. I'll just draw a little red link here between ingress and service. That's the big picture of the components I just mentioned before. I am going to be using a distribution of Kubernetes called K3S. So distributions exist because there's a lot of moving parts to Kubernetes and a lot of components. And so some folks have been kind enough to compile all these components together and write some, you can think of them as installer scripts that helps you get Kubernetes running on your own local machines. And I decided to use the one called K3S because it's quick to install and it's pretty easy to comprehend. I'm going to be copying over some commands here to my SSH connections I've made to my 3 servers here, Ubuntu test 1, 2, and 3. I'll be putting all these commands on my blog. I'll put a link to in the description below, so you don't have to try to type them off the video. You can copy paste what you need from my blog. So the first command here is curl, so that is like get from this URL, we're going to be getting an installer script and pipe that over to a shell where we're setting these environment variables. One is that we want a cluster initialized. This other one is that we want to not use a built-in load balancer that comes with K3S because we want to use a different one. I'll get back to why that is later. I'll run this first. Now that the first node is set up, we will print out a token that we've been needing to join our 2 other nodes to this cluster. I prepared a line for that here. Let me copy that over and explain it. So now this tab here is my second node, Ubuntu test 2, Again, we're getting the installer script from K3S's website, and we're passing some slightly different flags. One of them is that we're passing this token so that we can join the cluster that we have already started on our first node. This is the IP address of my first node. I will run the same command on my third node. I'll go back to the first node, and I can run this command, kubecontrol get nodes with the watch flag. That'll print out all the nodes in the cluster and watch for any changes. All right, let me rerun the command just to be sure. Yeah, it looks like all three nodes now show as ready, and they're all running the control plane, which means that we're running Kubernetes now in a high availability mode across these three nodes. So we're running the actual infrastructure of Kubernetes itself in a high availability mode. We won't just be running our own payload, like our own code, but also Kubernetes itself is running in a high availability mode. You could also run, you could have some nodes as your control plane nodes, as your master nodes, I suppose, and other nodes as worker nodes, where they will purely be running your payload, or as in like your own code. But I just decided this is a small cluster, 3 nodes, and I thought it's kind of cool that you can do this in high availability mode. So I could turn off any of these nodes, and I'll still have Kubernetes itself working, and obviously also the app that I'm going to be running on Kubernetes working. Let me stop this. Now, I had several issues I had to overcome when I was setting this up initially, and here's one line I thought was, I'll show you at least, that was useful to troubleshoot when you have issues with setting up K3S. It's just journal control, and this will just show you the log output of K3S. I'll just demonstrate. Here's the log output. You can use the arrow keys, uppercase G to go to the end, and you can troubleshoot from here if you have any issues with setting up, like your initial setup of K3S. Next, I'll run kubecontrol get all. This shows us all the objects in our cluster initially, and here you will already be familiar with some of the terms I mentioned before. We have some pods, there's some services, some deployments, and these are all things that are here initially, like on a you would say a vanilla cluster. There's some infrastructure that goes into Kubernetes, such as DNS server to something from metrics. This traffic is the ingress I mentioned earlier. So that's our initial blank cluster. Now, these commands, you'll learn them along the way as you get more proficient in using Kubernetes. But just when starting out especially, I found it really useful to have a web interface, a dashboard, where I could poke around and learn about the components that are in Kubernetes. So here's some lines to help install that dashboard. These first couple of lines just gets the current version number of the dashboard from GitHub. I got that, and this is the important line, kubecontrol create, and then it fetches the installer script, I guess you'd call it, straight from, like, for the dashboard, straight from GitHub, and creates that as objects on your Kubernetes cluster. So it's created, that looks successful. Now, in order to be able to log into the cluster, additionally, you need to set up some admin user account. So what I'm doing here is I'm running the cat command with this 2 arrow EOF. That means basically we're just writing a file called dashboard admin user YAML. We're just creating that file from the command line. It can be a little bit of a strange syntax if you're not familiar with it, but I'm basically just pasting in a file on the command line here. Let me do that. So now we got a file. You see we got this file created now. If I were to look at the content of it, that's the content I just pasted in. And there's another file. And then we can run our kubectl create command. It takes these two files I just wrote and creates those Kubernetes objects. Now if I do the kubectl get all again, at this point I expect the dashboard. Let's see. Yeah, we definitely got some new objects, as you can see. We got some pods in this namespace called dashboard. So these are all related to the dashboard we just installed. Now the dashboard it doesn't have an external IP. I guess it would be here if it did, but it doesn't. It's currently only accessible within the cluster, internally in the cluster. So to work around that, what I'm going to do is make a new SSH connection to any of the nodes. Let me just do it to node number 1 again. And this time I will forward my local port, so on this computer here, port 8001, to the remote port 8001 when connecting to this machine. Let's do that. And I'll just become root. And I'll run this command, kubectl proxy, which now listens on 8001. I'll open up a browser to a URL that I've prepared. The URL is localhost 8001, followed by some long URL here, but for now, just copy paste it. It asks us for a token, authentication token. We can get that token. Back here in our node, we'll run kubectl. We're running kubectl, describe secret admin user token. That fetches the token from Kubernetes's. You can think of it as a secret database that it has built in. All right, so initially we get an overview. We can go up here and change it to all namespaces, and then we're going to get an overview similar to the get all command I ran on the command line before, where we see deployments, pods, all the objects that are initially present on the cluster. This is going to be useful also for troubleshooting and just for learning about Kubernetes. Now, next thing I want to do is install this MetalLB. That, as mentioned before, will give us an external IP address to services who we set up to have external IP addresses. Because currently there's no way, like if you're on a cloud provider, the cloud provider has some like on their infrastructure some load balancers that'll plug together with Kubernetes. But since I'm running this on-prem, on my local machines here on my local network, we have to do something else, and this MetalLB is a software-based load balancer that gives you a virtual IP address, like an IP address on your network that is like external to the cluster, but not bound to any specific node. So that's useful when you want to host it. You want to host your software without being reliant on any one specific node. You could take down any of the nodes, and you can still always access it on this load balancer IP address. So similar to with the dashboard, I'm just first running, let me just get that again. I'll first run some lines to get the current version number of MetalLB. And then I will be running, first I'll run these two kubectl commands, which will fetch MetalLB straight from GitHub and install it. Furthermore, from the instructions of like the installation instructions on MetalLB, I learned that you also need to create a like an internal key, I suppose, for the nodes to talk together, I suppose, for MetalLB. And we need some configuration for MetalLB. The most important part here is you need to tell MetalLB which IP addresses can it use. So I went to the DHCP server on my local LAN, just my router under my desk, and made sure that the DHCP server wasn't giving out IP addresses in this range from 20 to 40. So we can safely use those IP addresses for MetalLB. I first wrote the config file here, just to the local directory, and now I'm going to run kube control apply on that file. Config created. Now, when I was setting up MetalLB initially, I had a lot of pain with it would keep flapping on and off. I didn't really understand. Like, I'd have an IP, then I wouldn't. I didn't understand why. It was because I hadn't initially disabled the other load balancer that was built into K3s, which, by the way, doesn't provide. I don't fully understand why, but it doesn't show. It doesn't give you an external IP address external to the cluster. So that was purely an internal load balancer. Whatever. I disabled that, and things are working a lot better. But while I was troubleshooting that, this command was very useful. Kube control logs. And here you specify a label, I suppose which app it is, Metal Load Balancer, some namespace. And across all containers. And this helped me finally identify what was the issue. I found here in the log an error message that was repeating. Helped me pinpoint the issue. So you might find that line useful. Next up, we'll be installing a local Docker registry. You could also push your app code to Docker Hub if you wanted, but I like better experimenting with everything locally, and also just gives me a better overview of what components are really going into this. So in order to, I'm going to be running the Docker registry outside of the Kubernetes cluster. This is a shame, because that means that now there is a single point of failure. That's like the node where the Docker registry is running. But it turned out to be very complicated to run within the Kubernetes cluster. I did manage, but it requires you to set up some mechanisms for the storage to be replicated across the Kubernetes nodes. And that's non-trivial, so let's wait with that. For now, just to get things started, let's run a simple Docker registry outside of Kubernetes. We'll just run it here directly using Docker itself. We'll just run on the first node. So I'm going to install Docker first. All right, I just skipped a couple of minutes of Docker installation there, but now Docker is installed. I can run this command. Docker run, listen on port 5000, and run the container image called registry from Docker Hub, and we'll name the container registry as well. All right, it fetched that. We can do a Docker list here to see that it is actually running up 3 seconds. That's good, on port 5000. Now we need to set up our Kubernetes cluster to be able to access this Docker registry. And to do that, we will create this directory in etc rancher k3s. We're going to write a file called registries YAML, specifying basically how to get to the registry called Ubuntu test1, that it's going to be using HTTP, not HTTPS. That's why you need to do something special here, because in this simple case, I'm not going to set up a whole SSL setup, so we need this config file for that reason. I'm going to paste that in here. And the same on my second and third node. All right. Now they're all restarted. That's good. Now we're almost ready to create our own code now and push it to actually run it on this Kubernetes cluster. But one thing I wanted to do first is just make sure that the load balancer that we installed previously is actually working. Let's just get all again here. And yes, we see now that the ingress, the traffic, has an external IP. Let's just try to access that. Yes, something responds. It says 404 because we haven't set up any ingress configuration, like we haven't created any apps on this cluster yet. So it makes sense that it says 404, but at least something is responding here on port 80 on the IP address. Also, I noticed, let's see the dashboard, that's probably because we restarted our K3s, no data available. Let's log out. It gets confused when you kind of restart it like I just did. We're going to be needing the, let's see here. This is the token. I'll copy paste the token. All right, we're back in. And I think here as well we could also see, if I do all namespaces, let's just look at services. Yeah, we see here the external IP addresses of, or IP address of the ingress. All right, we're going to be creating our app now. I'm going to be creating a directory where we're going to have our, hold our source code for our app, and we'll be cding into that directory. Next, I'm going to be pasting in some source code of an app. I just chose, in this case, to write a Go app, but anything that can run on Linux basically can run in a container and thereby can run on a Kubernetes cluster. So it could be a .NET Core app, it could be a Python app, PHP app, Ruby app, whatever you want, as long as it can run on Linux, it can be containerized. In this case, I chose a Go app, and it's a simple app. Let me just full screen this and explain. I have some imports, I have some string here with some HTML, an HTML template, and I have, here's the main method where I'm going to be printing out the word starting, and then I've set up an HTTP listener, you can say here, to just call the hello get function, which will just basically return this HTML filling out this HTML template here where we fill out a few things, node and pod, here node and pod. So it's going to show which node and pod are running on based on what is set in this node name and pod name environment variable. So if this environment variable is not set, it'll just show blank, obviously, and it'll print the date. Here, time.now. Pasting that in. Next, because it's a Go program, I'm using the Go modules style layout. I need these two files. And now I will be creating a Docker file where the first part of the Docker is like a two-part Docker files. If you're not familiar with them, this first part is based on one base image. Golang from Golang. So the Golang base image, that's just a Docker image that has the Go runtime, Go compiler built in. So this first part is just where I do Go build this program I just pasted in, and then the second part is the one that actually runs, where it ends up calling server. So we copy the server that we just built up in the builder part, copy that to the final image, which is a smaller image based on this Alpine Linux distro. So this is a very minimal image. It doesn't have all the Go compiler and stuff, because we don't need any of that now that we've made our Go binary up in the first part. Copy that into what's going to be our final image, and then it'll default to just run the server basically. Let's make that. Copy that over here. Let's build that. Docker is fetching the base images. And now Docker is running the commands in the first part of the Docker file. So it's building the Go program, fetching the dependencies, as you can see. So it compiled the Go program, fetched all the dependencies, and finally prepared the second part of the image, prepared the final image, which is going to be based on the Alpine Linux base image. So let's just test this completely, like just pure Docker here, not nothing to do with Kubernetes specifically. So I'm just going to be running the container image that I just built, which I had tagged with myapp1. And the program itself was listening on port 8080, as you can see. So we'll have the call docker run, and we're going to be forwarding 8080 to within the container 8080. It printed out starting, that's good. If I go to Ubuntu test 1, oh, I need to say port 8080, HTTP. Yeah, now it returned that HTML template, and it also printed out that there were requests. I just press F5 a few times. You see the timestamp updates, and nothing is shown because, like here for node and pod, because we're not serving this for these environment variables are not set, and they're not set because we didn't set them on this environment right here. We're not running this from within Kubernetes, so that'll come when we run within Kubernetes. Now we will push, we need to first tag in order to push it to our local registry, the image that we just built. Pushed successfully, it looks like. Let me run these two curl commands. First one will, let me run them, I'll show you. So it shows which container images are available and which versions of these container images are available. So these two URLs on the Docker registry, what they do. Now, that was just containerizing the app and not Kubernetes specific. That was just general Docker. This next part is the Kubernetes specific part. So we will create a Kubernetes, a K8s subfolder here. We have K8s subdirectory, and we're going to be pasting in this Kubernetes object here, the deployment. So most important parts here are, we have 3 replicas. And we're going to be using 3 replicas, and we're going to be using this container image right here. Port is also important, of course, and we want these environment variables set. Node name and the pod name. This down here is a hint that we want it to ideally put our pods on different nodes. I haven't had, like, this isn't 100% foolproof for me. I'm not sure why that is. But this is supposed to hint, at least to Kubernetes, to spread the load among the pods. And I want this for high availability. So I'll first put the file there. I got the file, and I will run kubecontrol apply on this file. All right, it says deployment created. Let me open my browser again. We should have a deployment now here. My app. Let's just reduce the noise. I'll just only look at the default namespace. Yeah, myapp1 deployment, pods 3 out of 3. Look like they're up. We can drill down a little further here. I believe you can see the pods. Maybe not. We can see the pods over here by clicking on pods, and we see there are 3 pods running, and thankfully they are on 3 different nodes. So that's what I wanted. That's good. Next, I will be creating a service. That's the grouping of these pods. I will just paste in the file and run the kubecontrol all in one. So, I suppose important in this one is the port number, obviously, and the type. You could also have set type load balancer, and that would have exposed port 8080 directly on a load balancer IP. We could certainly do that. It's useful though to use the ingress, which is going to be the next step, because then you could have several services sharing one IP, like one load balancer IP, and you can do the name-based routing, path-based routing, and you can do HTTPS. So generally, if it's a web app, usually folks use an ingress for that. So that's what we'll be setting up next. We'll create this ingress object, which is going to forward traffic to the MyApp1 service, I believe, right? Yeah, we have the MyApp1 service set up already. And let's set up this ingress. It says created. I should be able to see it over here, right, on this endpoint. Let's click on that. That was the one we already had open, and yeah, we got it. I can refresh, pressing refresh here, and you see the served from node changed, served from pod changed. So that's what we wanted. Another useful thing here, let me run this command, kubectl logs. This I thought was really neat, that you can now, because we have our app running on 3 different machines, you should remember. However, we might still want to look at the logs across all machines, and you can do that with this kubectl logs command. As I press F5 here, you see we get log entries it collects them from all the containers in all the pods across all the nodes. I found that very neat. Let me stop that. Next, let's say we want to make a change to our app. Let's say we want to change our app from, instead of printing test1, it's going to print test2. So let's change the source code. Here's the HTML template. I'll just change this to test2. Save that. And obviously we'll be needing to, we're in the correct directory. We will do the Docker build step again. This time I didn't need to fetch the base images, so it's a little bit faster. It's still fetching all the Go dependencies again because I didn't, you could do, a more correct setup here would be to probably mount some volumes where the Go package cache can write its files so it doesn't have to fetch them over and over again. But in this simple example, I was okay with it fetching it again. It built the container image. I'm going to tag it with, I call it, you see the difference here is I called it v2. I'll push it to my local registry. And then I'm running this kubectl set image command, which is basically equivalent of going into the YAML object we had previously created and changing the image. Recall, let me just Control C here. Previously we had in our K8 deployment, we had the container image specified here. We could also, and you might probably want to do this in the real world, change the container image here, save it, and probably check it in Git, and then reapply this Kubernetes object. But just to show there's different ways of doing it, I'm just going to run this one, which basically does the same. So that sets the image of this deployment to this v2 image. There's a neat command here to show the rollout status. It's already rolled out. If I'd been faster, it would have shown as it was rolling out, it would show the progress, but it's already done. That was quick. So if I press F5 here, yeah, now it says test2. One last thing I wanted to mention in relation to upgrading is that you can also roll back. If you run this command, rollout undo. Let's see the status of that. Then it should roll back from our v2 image back to the v1 image. See, it has successfully rolled out the rollback. So now it says test1 again. So that can be useful if you realized you've made a mistake in rolling out a bad image. Now the last thing I wanted to show is that to test high availability of our application. I found these commands useful just to get an overview of where the pod's running, like just the get nodes. Let me run that just to show you which nodes we currently have and their status. And this second command here has some extra parameters to print out which node a pod is running on. So this gets all the pods and which nodes they're running on. So if at this point we ran the command kube control drain, then it's going to start moving pods away from Ubuntu test 1 because I told it to drain Ubuntu test 1. We could also more drastically just have turned off Ubuntu test 1, but then it would take up to 5 minutes for the two other nodes to be completely sure that, okay, Ubuntu test 1 is down. It's not just a network glitch. Like if it was too fast to decide that that a node was down, it might not actually be down. It might just have been a network glitch, right? And that would be kind of a mess if it had already started spinning up the pods on the other nodes. So so therefore there's a pretty long timeout if you just like turn off a node. But if you actually plan for taking down a node, then you can run this command that I'm using in this example, the kube control drain command. Let's rerun the get. You see now Ubuntu test 1 says scheduling disabled, and almost everything has been migrated away from this node. There's something that hasn't, and that's related to some low-level networking components that simply cannot be stopped, but we don't need to worry about that for our case. I can demonstrate that we can actually, let's see, we should expect now our pods to be running on 3, 2, and 2. Okay. So if we refresh, 3, 2, and 2. That's good. Now, when we want to put our node back in rotation, we can simply run this one, on cordon and let's look at our status. Now it no longer says scheduling disabled, and I guess it doesn't eagerly move things over just yet, but anything new will be spun up where there's the most amount of resources available. That will be on Ubuntu test 1. So that concludes what I wanted to show you on how to get from some actual code to something that's running on a Kubernetes cluster. I hope you found it useful.